Today, I'm going to talk to you about how to process more than 100 million images per month with deep learning. This project was put in place at Linkfluence, a company that is doing social media monitoring. And they wanted to analyze what was in the images they are receiving. And they were able to detect things like pizza, brands, glasses, and of course, and this is my favorite state-of-the-art technology, Labradors. We had a few constraints with this project. First of all, we had to process each image at least once. This means that we can process an image twice, but we cannot miss any image. We also had to keep the cost as low as possible and to have a project that is maintainable. For all these reasons, we decided to use Kafka. Kafka is a really mature queuing system, and it has a lot of advantages. So the first reason we use Kafka is that decoupling is really easy. You just put the data, the images into Kafka, and the deep learning system doesn't have to know where they come from. It just has to process them. Also, the system is really robust. If your deep learning system crashes, you can still put that data into Kafka, and you have a chance to recover. Scalability is really important as well. If you have more and more images to process, you can just add machines, and they will reorganize themselves to handle the load. And finally, you are able to monitor the length of the queue. So because of this, monitoring is really, really important, and Kafka allows you to do many things with monitoring. So let me show you a few graphs from our monitoring panel. What you have here is on top right of the image is the lag in Kafka. So the lag is the number of images you still have to process. So you can see that it just goes up and up. It's because you are adding images, and then goes down. It's because you just tell Kafka that you just process a batch of images, and Kafka acknowledges that, so the lag reduces. You have to monitor this because if the lag gets too big, it is an issue. That's why it's a good idea to have a threshold on top of which you get an alert and you can act upon it. Among the other metrics we were monitoring was the count of the updates at the end of the pipeline. So if you stop updating your data store, you know that something is wrong. And also we had timers. We were timing the time that each deep learning model was taking. So if you do an update to your model and you want to know how it performs, you just look at the monitoring. And if the processing time doubles, you have an issue. So what you can do to act upon that is profiling. This is the TensorFlow profiler, but most of the deep learning frameworks have profiling tool. And what you can see here is that we have convolutional layers followed by an LSTM. And after a commit, we noticed that our model was taking more time than usual to process images. So we profiled it, and we realized that the LSTM was the culprit here. And we were able to change the LSTM cell and have our model run fast again. As a final note, I would like to mention how we were handling the models. So of course, we were versioning the models. We had a model repository. So for small models, Git does a good job for that. But if you want to do more complex stuff, such as A/B testing, TensorFlow Sharing is also very good at this job, and it also works with other frameworks. And as a final note, if you want to learn more on how to manage your models, I suggest having a look at Matthias Ordner's talk from last year at dotAI, where he explained how he trained a huge amount of model. Thank you for listening, and if you have any questions, please talk to me or reach me on Twitter. Thank you.